Hello and welcome to Multivariable Physics, Episode 1. Today we're going to be talking about scalar and vector functions. Hopefully you saw the last episode where I talked about prerequisites, what you should and should not know coming into this, right? What to expect as well, what we're going to be covering. So I won't go over that again. You can go watch that again if you need to. In this series, I'm actually going to just jump right into it. And we're going to start with thinking about functions in multiple dimensions. Because this actually is very relevant in physics. Because in physics, we're working in the real world. We have multiple dimensions of movement. You have your x, your y, and your z. And things. And also, which we'll get into later, we have spherical coordinates as well, so we can have things moving radially, we could have a radius, and then we could have some theta, and then maybe off of that some phi, and then this can parameterize some vector, some movement, some curve, right? So all of that, so knowing how to work with functions that take in multiple parameters or that spit out multiple parameters or multiple things becomes really relevant in physics, right? We can think of like a particle that's moving, right? That's you shot it from a gun and then it's slowly falling. We can think of the forces acting on this particle as being split into the x component of the force, and the y component and the z component. In this case, there's no z component, just x and y, right? But this would be gravity, and then this is going to be the gun, right? So it's really important that we learn how to think in terms of these functions. So let's start and define one of these functions. So let's start with scalar functions. All right. A scalar function, and if you're not used to this notation, you'll get used to it. What this is going to be is the domain is going to be here. There's our domain, and the codomain is going to be here. So this function takes in two parameters, two real numbers, and it spits out a real number. Okay, that's all that this is saying. So this takes an x and a y, and it maps this to f of x and f of y. Does that make sense? So to think of an example, okay, I'm going to think of something really simple. So we'll take this function, f of x y is equal to x squared y. Really, really simple. Another example, e to the y cosine x. Or maybe we have square root of y and natural log of x, something, right? Maybe this is actually natural log of x, y, this is actually y to the power of x. We can have something. It's just we take this x and the y and we combine it. We can have we can have constants like 2, maybe we have an arbitrary constant a that doesn't mean anything, right? I guess it's just a g now. And so these are scalar functions, and as opposed to vector valued, and these are often called scalar valued and vector valued, okay, as opposed to vector functions, okay. And vector functions are functions, or vector valued functions are functions that they take a vector, in this case a vector of 2 parameters, and they return a vector in something. So I'm going to use this shorthand. If you don't know what this is a Cartesian product. So R cross R is just all tuples, x and y, where x is x is a real number and y is a real number, right? That's all that is. And often if we have really large sums, right, we just use the notation x to the power. So this, we can use x to the power r or r to the power of n. This also is, if you're familiar with linear spaces, this is Euclidean, the Euclidean vector space. Usually, I'm running out of space, but basically this takes one vector of inputs and one vector out, right? So it takes an x and y, and then what does it spit out? It spits out f of x, y, so it spits out a vector, f of 2, f of 1, x, y. Okay, so these vector value functions become a little bit more relevant, and there's actually a really important relationship between these vector value functions and scalar value functions, which will help us in physics. But right now, a very quick example of a vector value function is, let's say we have the force acting on some particle. You shoot a particle out of a gun, flies out, and it slowly starts falling, right? Well, the force on this particle is a vector value function in x and y, right? And it's equal to, well, force of the gun, whatever that is, minus mg, right? And so that's the force acting on this gun. And so we can work backwards, and we can define the position r, right? We can go backwards, and we can define the position r in terms of f, and we'll get into how to do that in next episode. But this should be basically the introduction to scalar and vector functions that we need. Now we'll get into how we can actually use these, and first we'll actually get into graphing these, actually, like what does it look like if we actually graph these, and then we'll get into using these.